So here we're going to go over how to solve projectile motion problems, two-dimensional motion problems, when the object doesn't land at its launch height. So it's launched at an angle and it doesn't land at the same position from which it was launched. So we're going to start this just like we start everything. So here we can see that this is a projectile launched at a 40-degree angle with the horizontal at a speed of 75 meters per second. And here it lands on top of some structure that's 80 meters tall. So it lands on top of a hill or whatever. And the question is, how far away is the hill, is its landing point atop this 80-meter structure from its launch point? So that's what you want to find. That's delta x. How far did it travel horizontally to get to the top of that hill? So we're going to start this like we start everything else, with finding the x and y components of launch velocity. I'll just abbreviate them v sub x and v naught y. So this thing being launched at 75 meters per second at an angle of 40 degrees, part of that velocity, that initial velocity, is horizontal, and that's what we call Vx, and that is constant. There is no force along the horizontal, so that's constant. Part of that velocity is upward, and that's V naught y, and that's what we're going to calculate. We're going to use trig. When you do that, you find that Vx equals 57 meters per second, and you should be able to do this step without me going through it step by step by now. If you can't, go watch some other video, and I do go through it step by step, I think in all the other ones on this topic. And V naught y is 48 meters per second. So at this 40-degree angle, if I have an object, what this is saying is that if I have an object that's moving horizontally at 57 meters per second while simultaneously going upwards at 48 meters per second, overall its speed, if this thing slammed into me, it would be going 75 meters per second at this angle of 40 degrees. So I found that, and that is your first step to find that. And your next step is to list your variables and your unknown. So list your given variables and your unknown. And remember, we separate these into what's going on along the horizontal. That CV stands for constant velocity. It is still moving at a constant velocity along the horizontal. There's no force to change its motion. And Y, I'm just going to put FF here to remind me it is in free fall. And the first thing I can write there is that whenever something's in free fall, I know its acceleration is g, 9.8 meters per second every second. What else do I know? I know that delta x is my unknown. And I know that I just found the velocity in the x direction, which was 57 meters per second. I also found the initial y velocity. It was upward. This was shot upward, right? It doesn't go down. Overall, it goes up. So it was shot upward at an initial velocity of 48 meters per second. And so here I see acceleration is down and initial velocity is up. So I'm just going to, before I forget, make downward negative. Whenever I have vectors pointing up and vectors pointing down, I make downward negative. I could make upward negative too. I just have to be consistent. And now what else do I know? What else is known? Well, I know that it starts here and it ends here, right? So this displacement from its starting position to its ending position is its delta y. Forget that it moved horizontally. It started on the ground. It landed on top of some structure 80 meters tall. Its displacement was up, and it was 80 meters. And so we know in all of these problems, time is really the key. Time's the variable that's on both sides. Let's just see why. If I wanted to go ahead and see what was necessary to find delta x, well, what do I know? I know along the horizontal it's at a constant velocity. So what does that mean? It means the equation that I use is this one. Velocity is change in position over change in time. Therefore, change in position is going to be the velocity in the x direction times the total, multiplied by the total time it takes to get from here to here. I don't know what that time is. I'm going to have to calculate that. Excuse me, and when I do, I can just plug it into here. I already know the velocity in the x direction is 57. I'm going to multiply that by time. But I have to use my y information here to find time. So really, that third step, was jumping the gun a little bit because I can't solve it. I need to find time. How am I going to find time? Well, I don't know enough in the x direction to find time, but I do have a kinematics equation that has acceleration, initial velocity, displacement, and time. And it is this very same equation that we use all the time. I'm going to write delta y instead of delta x. This is so that I can be sure when I go back to my data, I'm putting in a delta y and not a delta x if I happen to be given that information. And I can make sure that I'm putting in the right information. So delta y is v naught t plus 1/2 gt squared. Every time we've used this equation to find time, something has gone away. Either the delta y has gone away, the v naught t term has gone away because v naught has been 0 or delta y has been 0, the total displacement. If it lands at its launch height, right? If it landed down here, this would be a parabola. If it landed down here, it would have landed at its launch height rather, and delta y would be 0, but it's not. So what I have here is a quadratic, and there's some video here that shows you how to use the quadratic to solve this. I'm going to go through the steps. The quadratic formula, if you are a little rusty here, is, let me write it down here, is a formula or an equation, ax squared plus bx plus c equals 0. So anything that can fall into this form, I can solve using the quadratic equation. And there's a little song that I'm not going to sing, but we know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is a quadratic. It has a squared term, and it has just this regular term, and it has a number here with no unknown. The first thing I'm going to do is set this thing equal to 0. So in order to get this equal to 0, I have to subtract delta y from both sides, right? To get 0 on this side, I have to subtract delta y. And what I'm also going to do is rewrite this so it's in this form, ax squared plus bx plus c. That just means I'm going to reverse these two things. So 0 equals 1/2 gt squared plus v naught t minus delta y. Why minus? Because I had to subtract it from this side. I had to subtract it from both sides. In terms of switching these around, 1/2 gt squared plus v naught t versus v naught t plus 1/2 gt squared, it's the same thing. Think about 2 plus 3 versus 3 plus 2. It's the same thing. So I can switch these around as much as I want. And I get the same answer. So now I've put this in this format. Let me write it over down here. 1/2 gt squared plus v naught t minus delta y equals 0. Well, this is a quadratic, right? I know what my a is, my b is, and my c is. Let me just mark it for us here. This 1/2 g is a. This v naught is b. And this minus delta y is c. And you got to keep track of that negative sign. So all I have to do here is put it into this equation. Normally I make you guys isolate. I'm not going to make you do that now. I'm going to let you put the numbers in right up front. So we're going to actually, instead of leaving this 1/2 g and isolating it and putting it in here, we're going to put in what 1/2 g is. G is negative 9.8. Half of that is negative 4.9. T squared plus v naught is positive 48. T, notice I don't make you put in units on this either. And delta y is positive 80, so it's going to be minus 80 equals 0. Now it's in that format. Now I'm just going to carefully stick it into this equation. I'm not solving for x. So the variable I'm solving for is called t, but it's all okay. T equals negative b. Well, b is 48. My b term is v naught. It's 48 here. So negative 48 plus or minus the square root, and I'm going to put the radical on at the end to make sure it goes over the whole expression here. B squared minus 4a, keep track of that negative sign. C, make sure you keep track of this negative sign. C is an 80, it's negative 80. All over 2 times a, so this is going to be all over 2 times negative 4.9. You can put this in your calculator. If you have a scientific calculator, you can put this in negative 48, and you have to do this separately. As far as I know, I don't know that there's any way to, maybe there is, in your calculator to put this in as a quadratic, but you have to do it separately. Negative 48 plus, open your square root, then just put this in, 48 squared minus 4 times negative 4.9 times negative 80, close your parentheses, hit equals, divided by, and then in parentheses 2 times negative 4.9, or you can just do negative 9.8. When you do that, you're going to get two answers. When you add, you're going to get 2.1 seconds. When you subtract, you're going to get 7.7 seconds. My goodness, what do? We got two answers. They're both positive. Sometimes one is negative, and I can throw it away, and it's easy to pick which one I should use. Here, it's pretty easy to pick which one you should use, too. What I just solved here in red is I found out how long it takes for an object launched upward at 48 meters per second to reach a height of 80 meters. That's what all this math is for, is really answering that question. In the presence of gravity, you launch an object upward at 48 meters per second. How long will it take to get to a height of 40 meters? We can see in this diagram, it's not the best diagram, but you can see that it reaches this height of 80 meters twice. It hits it here on the way up, and it hits it here on the way down. It's at 80 meters 2 times. And in fact, if we have any projectile, I don't know if I'll be able to draw a better picture here, but any projectile, you could pick a height. So let's say it follows this path, and let's say this height is 10 meters. Well, we can see that it's there twice. It's there on the way up, it's there on the way down. If we want to know, well, when was it at 20 meters? It's there on the way up, it's there on the way down. So both of these, it happens twice. When you have a situation like this, an object reaches that height or that position, distance from its starting point, on the way up and on the way down. So that's why we get this. This was, at 2 times. It arrived at 80 meters at 2 different points in time. One was at 2.1 seconds. That was on the way up. How do I know it was on the way up? Because 2.0 seconds happens first. The event at 2.1 seconds happens before the event at 7.7 seconds. And I can look at this and I know that it went up before it came down. So this was when it reached 80 meters at 2.1 seconds. This is when it reached 80 meters at 7.7 seconds. And I'm going to use the 7.7 seconds. Why did I just do all this? I just did all this to find delta t. So let me solve it over here. Delta x equals velocity in the x direction, 57 meters per second, times time, which I'm going to use the 7.7 seconds. And when you solve for that, you should get 440 meters as that range. And that is how you solve this problem.